Hello and welcome to this month's PrinterView. The PrinterView is a new series where we are going to talk with some of our 3D printing customers to learn more about their business and how they're using their printers. Hopefully this will be entertaining and educational, giving you a deeper insight in the additive manufacturing solutions that's out there in the market and what they can be used for. And today I have invited Mikael Omlid from OsloMet for a chat. If you have any questions during this webinar, click on the icon shown in the picture to submit them. So if you click on that one, you will get this chat screen and you can type in your questions. And we will gather all the questions after the webinar and send out an email to all attendees with all the questions and answers so that you can get what you're after. So, my name is Stian Mork. I work as an application specialist in 3D printing for PLM Group, Norway. And as I said, with me today, I have Mikael Omlid, who is working as a shop foreman at OsloMet, which is a university based around the Oslo area, Norway. So, Mikael, would you like to tell us a little bit about yourself?
Yeah, as Stian said, I work at OsloMet, which is a university in Oslo, and we have campuses around Oslo as well. I work specifically at the Department of Product Design, where we teach product and industrial design to bachelor and master students. My background is varied. I'm originally a musician and sound engineer, program engineer for radio, which was where I got my education. But I've always been interested in the maker movement and making things, and I've always been very fascinated by machining, traditional machining, and eventually I also got into automated machining, so building my own CNC machines and 3D printers and things like that. And that interest is why I got the job at Product Design. We need staff there who have varied experiences and can guide the students through all different kinds of processes.
Yeah. So we have been working at OsloMet for
9 years.
9 years. Yeah. And how long have you been into additive manufacturing?
Almost the same amount of time. I started using my first 3D printer when I started at the department, and there was no one really there who had much experience with it. They'd just gotten funding to buy printers, and nobody really used them that much. So, and I was fascinated with it, and sort of built up the rapid prototype lab at our department from there. So. Yeah, the last 8, 9 years I've been working with printers.
Yeah, that's quite a long time. The university, OsloMet, is quite a big university. How many students are going?
We have currently it's about a little over 20,000 students at the university. At the Department of Product Design, we are only about 160. In both in the bachelor and master studies altogether. So we have about, in bachelor, we have about 40 to 45 new students every year.
Okay, that's good. You have, I've been to university and I know that you have quite a big machine shop.
Yeah.
With a lot of cool tools. What do you typically use this machine shop for?
Our machine shops and our material accessibility is something that we are very proud of. And as we see it, design schools are going more and more towards screen-based design where you do a lot of CAD work and rendering only and you stop there. We are very true to the fact that consumer products need to be physically prototyped.
Yeah.
We need physical models to both understand the product and understand the user's need in those products. That they have to be handled, they have to be realized in the physical world. So we have very large wood, metal, ceramics, plastics workshops where our students can realize those physical prototypes and go through the whole design process of everything from their first scratches on a napkin to actually realizing the physical product in the end.
Yeah, so you can go through the whole process.
Yeah, that's very important to us.
That's cool. I know that you also have quite a large number of 3D printers at your facility. How many printers?
I believe, kind of losing count, but we have, most of our printers are what you would call low-cost FDM printers, typical plastic extruders, which was something I was very adamant about introducing to the school, because the original printers we had were very expensive and the students had very little access to them because high print costs and stuff like that. So I wanted to introduce more cheap, low-cost printers that the students could use themselves. So at the moment we have about, I think about 15 FDM printers, and then we have some more specialized printers, 3 or 4 of them that the students don't have direct access to, but they have access to them through me. So when they have finished, gotten to a point where they have printed them in PLA or something like that in a typical FDM printer, and they find that, okay, this quality isn't good enough for me, it doesn't hold the tolerances, it's not strong enough, then we can go on and we can, for example, use the Mark IV printer or SLA or other printers like that.
Okay, so the students do a lot of the printing themselves, the low-cost machines. Yeah,
they have some printers that are in their classrooms, which they operate and maintain themselves, also break themselves, and so they have to fix that. And then I have about 10, 12 printers in Additive Manufacturing lab, which I maintain, but they have access to them during daytime. And then, so they'll typically start prints during the day, and then they'll run over through the night and be available the next day.
Yeah. Yeah. Cool. So, since you've been into the additive manufacturing business for 9 years, that's quite a long time. I think that this is still a new business. Or what are your experiences with AM compared to traditional manufacturing methods?
I guess my whole view on digital versus analog, if you can call it that, is I feel today a lot of people are trying to make this into 2 camps, like digital versus analog. I've always had the view that these are tools. So if it's an expensive nylon printer or something like that, or it's a hammer, it's still a tool. So I don't see the difference between a traditional, like you see on the picture here, a traditional metal lathe, or if it's a fancy 3D printer. They are tools. You use the right tools for the job you're doing. And you do use the tools that will give you the results you want in the fastest, cheapest possible way, without compromising on your requirements. And so I've never set additive manufacturing against traditional machining. I would not use a 3D printer for a part that I could just as well go and do on a manual lathe.
Yeah, makes sense.
I want the part and I want the result as quickly as I can. And if that's done with a 3D printer, then that's the tool I'll use.
Yeah, and as you know, we still have to do quite a lot of post-processing with traditional tools.
Yeah, so that's something our students learn very quickly, that they've heard about 3D printing and think, oh, you just push a button and you'll get it. But then if you haven't done the work, if you haven't modeled the part properly, then the 3D printer will give you nothing. It will give you exactly what you put in.
Yeah, it's almost that way. So on the screen here, of course, you can see some traditional manufacturing tools. What you see on the screen now is a picture of a 3D printer from a company Markforged. What's special with these printers is that they are able to produce fiber reinforced parts, meaning that you can have plastic parts with either carbon, fiberglass, Kevlar, and so on embedded inside them, making them super strong. Compared to traditional, as you talked about earlier, FDM machines that make just pure ABS, PP, and so on. I have this part with me, which is printed in the Markforged. So I was just thinking of showing you a physical test of how strong this material is. So I will just switch through to my mobile phone camera. So if you can just film me, Mikael, and just take it on standing first, and if I just stand on it.
And it didn't even break.
Yeah, no. Still as new. And if I put it down this way, which would be a little worse, a little more loads, you can see that it's still, it's maybe not as strong as it was, but just permeate a little, and it's as new. So this is really strong parts, and because you have the fiber reinforcement, you can make parts that are comparable to almost metal.
Yeah, so almost aluminum strength on certain parts.
And these Markforged machines, here's an overview of the different machines and the printers. And these printers are using FFF or FDM, based on what you call it. There's a different name on these technologies. Fused filament fabrication. So that means that it builds with a filament which is melted onto the build plate, layer by layer, and then you build up the physical part. Another cool feature with these printers is that you are able to pause the printing midways in the process, and you can incorporate things like electronics, batteries, magnets, and so on, and then you can continue printing, so these elements get enclosed into the geometry. I think that opens up for a lot of new ways to produce things, to incorporate elements into the geometry. So what you see here on the top, it's the desktop composite machines. This is typically desktop printers for prototyping. The first one is called Onyx 1, which is able to print onyx material, which is nylon with chopped carbon fiber inside it. So it's still strong, but it's not as strong as the one that you get with Onyx Pro, which is onyx material with fiberglass for higher strength. And then we have the Mark II, which is still onyx, but it also opens up for fiberglass, carbon, Kevlar, and what we call HSHT, which is high strength, high temperature fiber, which is, I think it's like 5 times stronger than fiberglass. So those are the desktop composite series, and then we have the industrial composite, which is it's the same materials. So we have the Onyx 1 and the X3 is the X3 is also only onyx, and then you have the X5, which is onyx and fiberglass, and then you have the X7, which is onyx and all the different fibers that are available. So it's the same materials, but they have bigger build chambers. They have calibration lasers and so on. So they have more industrial features than the desktop composite machines. And they're also able to print down to 50 microns compared to the desktop machines, which is able to print out to 100 microns. So they can print a little thinner layers. And at the bottom here, can see something called Industrial Metal, which was launched late 2018, and these are printers for printing metal parts. We will talk more about the Metal X, which is called the Industrial Metal Machine, afterwards. And you have 2 printers from Markforged that are delivered from us in PLM Group. Mikael, you have an X7 and a Metal X.
Yep.
You can probably tell us a little about these printers. We can start with the X7.
Yeah. We've had the X7 for almost a year and a half now. We got it primarily, it was a collaboration between us and at the Department of Product Design and Orthopedic Engineering Department. What we were looking for was the ease of FDM printing, or FFF printing as Markforged calls it, but with higher strength. We wanted, especially for the Orthopedic Engineering Department, they wanted parts strong enough to be used in prosthetics, and that they could be used directly by the user without having to go through stages after additive manufacturing to make them strong enough. The fact that we can print parts with selective layer reinforcement, where we can decide where we want to put the carbon or Kevlar reinforcements, really realize that option for us that we wanted to try. So it was what we had read about it, and also the parts that we had seen, that was the reason why we went for that printer.
Yeah, and you said that you can choose how to orientate the fibers inside it, and here you can see a picture showing that good. Where we have this is fiberglass, which is oriented inside the Onyx material. So this is how you can build it. As I said, it's super strong. So
I should say that the Onyx material itself, I mean, most of the prints we have done is only with the Onyx material, which is, like you said, it's nylon with chopped fiberglass particles to it, and it is super strong on its own. But the ability to have continuous fiber reinforcement in layers that you really need extra strength is a very, very nice feature.
Yeah, I mean, you can print Kevlar, which means that you can build yourself a bulletproof vest.
Yeah, I don't know if I would use this technology there, but
in theory.
Yeah.
Yeah. And that's the X7, and then as mentioned, it's the Metal X machine for printing metals. And we are currently installing that at your university. So unfortunately we haven't been able to test it yet, but we're really looking forward to see how it is compared to the traditional SLM machines that's out in the market. So just to give you a little insight in what the Metal X is, it's actually revolutionary in terms of metal printing, because it uses a completely new technology, which is called ADAM. It's building on the fused filament fabrication, like the other machines, but it's metal powder bound in plastic. So you have the filament, but inside the filament it's metal powder. So you print it like a traditional FFF, one layer at a time, and then you take it into a washing machine and you wash out most of the binder material. So what you end up with more or less like a Swiss cheese. It's a part with a lot of holes in it, and then you put it into a furnace to sinter it at high temperature, and it will like fuse into a solid metal part, and then you will end up with a pure metal part, which is ready for use. That's that's the process. So yeah, we're really interested in seeing how this will be. I know this is maybe a little difficult question, Mikael, without having tested it yet. How do you see it? What do you think is the biggest benefits with the ADAM technology compared to the SLM, selective laser melting, traditional?
Well, even though we haven't used it yet, as you say, part of it is not hard to answer at all, because a traditional powder-based metal printer would not be a viable solution for us. We would very much like to be able to print metal parts, but all the safety and handling concerns you have with powder-based metal printers is not something that we could accommodate in our workshops. It would just be too demanding. So the fact that Markforged has this possibility or this technique where you more or less FDM style or FFF style printing, which we are very used to, and then but getting a metal part out the other end is very interesting. And also just the financials of it. A typical powder-based machine would also be too expensive for us. We could not sort of justify the cost in regards to what we actually need at the department. Where this technology is more, it's easier for us to acquire.
Yeah, I would say maybe if you can say that metal makes this more for prototyping, one-off, then you might go for the SLM technology if you want to have larger batches, print more.
So for our prototype work, this makes most sense.
Yeah, sure. And I have also a picture here showing some different parts that you can get out of the machines. We actually also have a component that we were sent from Markforged, which you can see here. This is I can switch to full screen. So this is something called a ball joint. So what it is, it's two different components which are screwed together, and as you can see inside it, it's threads. So it's internal and external threads, and these are printed in two parts, and they are able to be fitted, screwed together.
And those threads, they are straight off the machine. They are not machined in any way afterwards. They are straight off the printer, and they work.
It's really cool. So this is in stainless steel, 17.4, and it's also now possible to print in tooling steel.
Yeah.
And there are more metals to come later this year, probably.
Yep.
So it will be really interesting. There's maybe some of you viewers that haven't done any 3D printing and doesn't have any experience with 3D printing from before. Mm-hmm. Could you please try to explain a little about how you work from design to finished 3D printed products?
Yeah, I mean, the process is, if you have done any, I mean, the design process before, then, I mean, for students, it can very quickly or easily start as just a hand-drawn sketch, an idea, a concept model, and which they will then take into their CAD program. Mm-hmm. And refine it there, get a 3D part out of it, and which they will then export and bring into what we call the slicer, which processes the 3D part and makes it ready for the 3D printing process, where it's sliced into individual layers, and then that you can then send to the printer, which will read that file coming from the slicer and make the physical part.
Yeah, so then you end up with the 3D print. So you can say that the slicing software. So you first have the CAD model, right, which is often SL OsloMet, and then you take it into the slicer, which for Markforged is software called Eiger, which is cloud-based. So you put it in there, and then you slice the parts to take out the cross sections, depending on how many layers and what thickness you're going to build it with. And so you could kind of say that a 3D printer is printing 2D, but it does it like 2, 3, 5, 4, 500 times, depending on the number of layers. So it prints one layer at a time. The Eiger software, just
back to the Eiger.
Back to Eiger.
Well, I liked the Eiger software the second I saw it, because like I said, I've had quite a lot of experience with the FDM printers. I've used a lot of different slicers, both open source and closed source slicer softwares. And typically for a regular FDM printer, you might be using a slicer that was not specifically designed for that printer, which then gives you access to a lot of the different parameters, which is perfectly fine, but you need to invest quite a lot of time to get to know the printer and tune your slicer to work with that specific printer, making a print profile for that printer. Where the Eiger software is made specifically for their own printers, which makes it a whole lot easier. You don't have to deal with all the different parameters. Markforged has found settings that work really well for that printer, and which gives you very reliable results. So that was my initial impression of Eiger, and I still hold to that. It's been very easy to use.
Yeah, that's my impression as well. That they have like reduced the number of options, but you still you have what you need, and based on that you get out also what you're after. So
typically with a low-cost FDM printer that prints in like PLA or something, then you have the room to do a lot of experimentation. When you get to a point where you want to make a part in a Markforged printer, which I would say is a way higher class, also higher cost, certainly than regular PLA. You want to make sure that when you push that button, you press start, you want the part. You don't want 10, 15 tries to tune everything in to get it perfect. You want it right the first time, which it has done.
Yeah, I think that's important.
In a year and a half, we have had very, very few failed prints, which is really impressive compared to other machines we use.
That's good. And talking about prints, I know that you have some examples with you today to show us. So I can just switch to full screen again, so it's easier to see.
Where should I start? I have some student examples. I have one student who has who does work with paintball and airsoft, so that is where he puts a lot of his design creativity into, and he has made a headset here with heads-up display, display screen in here, which it's not a completed prototype yet, but it is. It will be attached to the headset itself, or to the goggles, and this whole casing here, and also the casing on the back of the headset here, were printed in the Markforged X7 printer. These needed to be very rugged parts because they're used outdoors and they are used in a very hostile environment in regards to dirt and water and things like that. So these are bolted together. Here you have the same part straight off the printer, sort of clamshell design. So that's another part from the same student is a gearbox for an airsoft gun, where he also needed something stronger than a regular FDM printer would give. This needed to be used in place. It's not just a mock-up prototype. It was actually a functioning prototype that needed to withstand the stress of being inside of that airsoft gun.
So you're like combining like metal and the plastic parts.
Bearings put into the print on the sides there, and
it's really cool.
Yeah.
Yeah.
Here we also have a very quick mock-up model we did for the orthopedics department, which is sort of a blade prosthesis. This one has Kevlar reinforcement, which makes it quite stiff. Again, we also have another one where we have carbon fiber reinforcements, which is even stiffer again. And then we did one without any reinforcement, and you can very easily feel the tension difference in those. We've also done some something like this where we needed a spring, which we did not have the opportunity to do in steel. It was for a very specific part, and it is carbon fiber reinforced, and it is actually very stiff. It was for sort of a catapult. It's quite low profile, and it needed to be strong. And this has, I don't know how many hundred cycles this has gone through, but it still has its strength. So it's the fact that you can print springs is quite cool.
Yes. How long time would you say that it would take to print this part?
Something like that. With the continuous carbon fiber, which adds some time, it's about a 4-hour print maybe.
Oh, okay, yeah, that's not too bad.
No.
That's good.
Then this was more this dental piece here. This is something you would typically print on an SLA printer. But we tried, and this was to sort of realize the quality you could get out of the 50 micron layer height, which is not much. Wait, it's mirrored here, which is really not any lower quality than I'm getting off our SLA machines. So that was it's not something you would typically use an FDM machine to print these sorts of parts, but
yes,
but the surface finish and the detail is quite amazing.
It's really detailed.
Yeah.
To be an FDM part, that's for sure. Yeah.
Here we have a small landing gear for a model airplane, which needed to be strong. So this is not carbon fiber, continuous carbon fiber reinforced. This is just the onyx, so the nylon with the chopped carbon fiber, and it's still very strong.
But it's, and I can see that the surfaces are quite good. What do you say, like post-processing? Do you do any, like, you have to work with the surfaces and so on?
No, not really. The support material is surprisingly easy to remove, considering the fact that the support material is the same material as the print material. Yeah. But and where you have other FDMs where you're using water-soluble supports and things like that, which makes it easier to remove. In the Mark IV, you use the same material, and I have never had any issues removing the support material.
Oh, that's good. That's good. Because that's also something you have to think about when doing 3D printing.
Yeah.
That, there's always some post-processing, but my understanding with the Mark IV is that it's quite easy to get the parts finished.
Absolutely.
Yeah. And yeah, thank you for that, Mikael. If you now sit and are interested in the MetalX printers, we will do a workshop at your university at OsloMet, 7th of February this year, hopefully.
Yep.
And yeah, you're free to come and visit us there. 10 o'clock. You can see that there's this sign up sheet online at pilmgroup.no event MetalX workshop. You can see the link there. So that's for the MetalX. We will also do a MetalX workshop in Denmark later this year, once that's in place. And you can, of course, you're also very welcome to come visit at our main offices in Norway, Denmark, Sweden, or Finland for a demonstration of the Mark II, maybe, or other printers that we deliver. Just just come by. Yeah. So that's it for this month's print review. Please stay tuned for more print reviews coming in the future. And after that, thank you. Thank you for coming.
No problem.
Yes.
Thank you.
Bye-bye.